And like having kids, you gotta take care of them, you gotta walk them, you gotta feed them, you gotta clean up their poop, you gotta get a babysitter when you wanna leave them. Doesn't that sound like having a kid? Yeah. Yeah, I stopped having kids. Where's your buddy? That's how I know. Okay. So, pretty well, I'm gonna talk. So pretty well.
I would go Disneyland just for the experience. Disneyland is Disneyland. Now, oh hell no. Universal Studios is not my favorite. I like you Harry Potter stuff, but so guys, this is not how you do your homework. I'm just showing you what you're going to be given and kind of how we do it, okay? So, with this being said, how would I figure out what this equals? Say what? So this guy actually needs an x plus 2, doesn't he? So does he. You guys agree with me? What does this guy need? Minus 1. So on top, I have 2x plus 4 plus 3x minus 3 over x plus 2, x minus 1. Right? Which is what? 5x plus 1 equals x plus 2, comma, not comma, parenthesis, x minus 1. Okay? You guys all agree with that? That's not our lesson, though. Our lesson says this. I'm going to take this 5x plus 1 over, what was those two things? X minus 1 and x plus 2. And we're going to figure out these other fractions. They're called partial fractions. Okay? So we want to know what two things added together, or three things, or four things, or whatever, added together to be this fraction. We're going backwards. So let me just go for it here really quick. Do we know, because I see two things down here, I think that there could be two items. And I don't know what over A is. I don't know that number on top. And I don't know what number's on the top of this guy. Well, technically I do since it's last problem. But I have to go ahead and say, okay, well, I assume because there's two parts, I could have two parts to these two fractions, correct? Does that make sense to everybody? Could I actually have a third part? Sure, with actually what the denominator is, but I don't have to do that. Okay, so now I'm here. And the reason why I did A and B is because I don't know what those values are. Once again, I do because I know what it was from the last one, but I don't. So I'm going to go ahead and times this by the common denominator of all three things. What is the common denominator of all three things? X minus 1, x plus 2. I'm going to times it to all three things. I'm going to times it into him. I'm going to times it into him. I'm going to times it into him. All three terms I'm going to times it into. Notice when I times x minus 1 and x plus 2 into the first guy, I am left with just 5x plus 1. Correct? Any questions there? Equals, now if I times it into here, what cancels out here? Does both things cancel out if I times it into the one with the A? Who cancels out there? So I'd have A times the part that's left over would be x plus 2. Would you agree with that? Does everybody agree with that? What would be left over with the B part? Yes. No, ma'am. I'll show you one in just a minute why it wouldn't work like that. Okay. Now I'm going to distribute, because if I had a 5 here, because once again, doesn't that A represent a number? Let's say, what would we do? Well, I'm going to distribute it through. So I know that I have AX plus 2A plus BX minus B should equal 5x plus 1. Now I have a question for you. Do you see how this guy has an x and this guy has an x? What if I knew what A and B was? What would I do? I would add them together, right? Well, I don't know what they are, so what am I going to say? A plus B. I don't have to put the x there. I mean, I could. But A plus B, guess what he equals? 5. Can anybody explain it why it has to equal 5? Because if you'll notice, this is also x. So shouldn't the things with x's on the right side equal the thing with the x on the left side? Doesn't that sound reasonable? Okay. Now what about the things without variables? Okay, such as this guy and this guy. Well, I know that 2a minus b should equal what? 1. And now, guys, I have a system of equations just like we learned, didn't we? Hence why we had to learn the system of equations before we went ahead and did partial fractions. So I'm going to add those two rows together because the b's will just cancel each other out, right? So I get 6 equals 3a. So therefore a is 2. Then I plug it back in. 5 equals 2 plus b. So therefore b equals 3. Would you guys agree with that? Now notice, guys, this is what it would be then. So this is how you would write your answer. 5x plus 1 over x minus 1, x plus 2. Are those the two things that were underneath it? Yes or no? What was first? Did I have a over who? Was it the x minus 1? So a was 2 over x minus 1 plus 3 over x plus 2. You see how I found it out with not knowing what those were? That's actually pretty cool if you think about it. I can decompress or undo a big fraction into multiple little fractions. Okay? Everybody there with me? Any questions besides Tommy that keeps saying yes? Everybody else is out of it. Really, no Maddie Dunn-Nesper? Huh? Where's Bridgie? Where? HOSA? Health Occupation Student Association. I don't know if that's it, but I made that. Okay, let's do this one. Will you tap him? Because he asked me a question the other day when he was sleeping, so that kind of frustrates me. You don't get to sleep when you get to ask me questions on how to do stuff. You did. One day. Not today. On one of the days that you were learning, and you decided to sleep, and then you didn't know how to do stuff all the way. Usually I let people sleep, but not today, brother. You made your choice. That was a good sawn logs, though, by the way. That's really what got me. You started snoring a little bit. It's okay, though. We all snore. I even take blame for my wife snoring. Like if I ever sleep in the same room as somebody else, my wife snores, I'm like, oh, I'm sorry, guys. I was such a snorer last night, so she doesn't get it. Isn't that nice of me as a husband? I'm taking the blame for the snoring. It's like Prince Charming here. Okay, this, you guys remember, we're going to do factor by grouping. What do these guys have in common? X squared, so what's left over? X plus 2. What do these guys have in common? -1, and I'm left with x plus 2. So I with x plus 2, x squared minus 1. Does anybody remember what x squared minus 1 is called? Difference of squares, which go into conjugate pairs. Does everybody agree with him? All right. Okay. Now, with that being said, okay, this time, look how many things I have. I have 3, don't I? So up here, I'm going to have a over x plus 2, b over x minus 1, plus c over x plus 1. Does everybody see that? Any questions on how I got that? Yes, Sid. No, ma'am. In the end, as long as you know that you're solving, the a is the one above x plus 2, it's fine. Could I put c there? Sure, but understand when I put a c there, that's the value that goes above x plus 2. So there's not technically an order because, once again, that's commutative. I can maneuver those around if I so chose, right? Does that answer your question? Sid and Sid's friend, thanks for the dogs. All right. So on this one, I'm going to multiply everything by x plus 2, x minus 1, and x plus 1. Am I not? Is everybody there? Is these always fun? Sometimes they get tedious and a little bit longer, and it's okay. Just understand it can get a little bit, you know what I mean? So here we go. As I multiply that through, don't I get exactly what I have over here, 5x plus 7? Guys, if you don't just get this, you did something wrong, because that should be your common denominator right here, right? You with me on that? Okay. Who said, did Aiden get out, or is he still here? Was he here last time? He got out? He mentioned it one time, so I didn't know if he decided to. It's always, because no matter what I'm timesing by, will always be my common denominator. If you times something more than your common denominator, you did something wrong. Okay. Because then if something else was there, then that means that would have been the common denominator. Does that make sense? So now when I times this, see, notice the x plus 2's get rid of each other, right? Do you guys agree with that? So what's left over? A times who? X plus 1. What's x minus 1, x plus 1? Can we just write it like that? Does everybody agree with that? How's the soccer going? Yeah? Bingham. Why? Yes. Can you? Well, that's what you guys think happens, and maybe they then take it upon themselves not to give you good calls. Sorry, brother. Okay. Does everybody understand how the x plus 2 and the x plus 1 would be the leftovers on that guy? Yes, no? Tom? I will get them in just a second. I'm just right here. I'm just going step by step right now. I don't want to overwhelm everybody. You get what I'm saying, though? Plus C, notice that would be x plus 2 and x minus 1. Agreed or disagree? Okay, so now what I want to do is, just like Tommy just brought up, really I want to go ahead and get these through. So this is x squared plus 3x plus 2. This right here is x squared plus x minus 2. And so then when I distribute them through, I get ax squared minus a plus bx squared plus 3bx plus 2b, or not 2b, plus cx squared plus cx minus 2c. Does anybody have a question on how I got that? I just distributed the a through each of those quadratic terms, correct? Now, once again, this equals this 5x plus 7. Now, the difference on this guy is, notice, guys, over on this side, I have some x squared terms, don't I? Do I have any x squared terms over here? So what does that mean that a plus b plus c should equal? Because it has to equal 0, because I have no x squared terms on the left-hand side. Does that make sense? That one's a little tricky for people to think about. Because I have no x squared, so I know that a plus b plus c has to equal 0. Okay? Now what equals 5? Who equals 5? The number in front of x's. Well, that's 3b, because that's the number in front of x. Does everybody see that? Oops, sorry. Let me go ahead and put him underneath where he needs to be. Okay, and C. And then 7. And then once again, I like to go ahead and kind of get rid of the terms that I've used so I know what's left over. I also know negative A plus 2B minus 2C should equal 7, because those are all the terms without a variable, right? Does everybody see all those? Are we understanding why it should equal these values? Because when I combine like terms, it gosh darn better, those coefficients, those numbers better equal the coefficient on the number side, right? Go ahead. Do you see, well, meaning like an x variable? Yes. Do you really, let me show you actually a different way really quick, if you don't mind. You mind going on a little subtract for me? Okay, so I'm going to combine everything with x squared. So I have ax squared plus bx squared. Does that make sense? So therefore, isn't and plus cx squared. Sorry about that, I lost one. Excuse me. So if I pull out that x squared, then I'm left with a plus b plus c. Right? So who on this side has the x squared? Because shouldn't a plus b plus c equal to the thing over there? Which I don't have one, hence why it's equal to 0. Then here, now I'm going to combine this guy, 3bx plus cx. That's equal to the guy over here with 5x, correct? Because notice, what could I factor out here? And then I'm left with 3b plus c times x. Well, x times something should equal x times the something. So therefore, the things with just x better equal the guy over there with just x. And then the things without a variable like x, negative a plus 2b minus 2c, they don't have an x variable, better equal the guy without an x variable. Does that answer your question? Does everybody understand that? It's actually the key idea of this whole idea, so you got to know that rule. Because if you'll notice, there's no just plain x's with a. And then notice I have 3bx right here. And then I have a cx right here. Because once again, it's the coefficients. Shouldn't, if I have x times 3b plus c, equal to the guy out front of x as well? Exactly, ma'am. Does that make sense? Good question. I really like that. Thank you. Tommy Jack, are you going somewhere this Saturday? Are you cereal, Tom? I'll be okay. All right, Tom. It's all right. Now, isn't this a 3x3 system? What variable would I like to eliminate? A, because already my second line already has A missing, right? So therefore, I want to get rid of A. And notice that's pretty simple. So here's the other guy. 3b plus c equals 5. That was already given. But when I add row 1 and row 3 together, I get 0 A's, 3 B's, negative C equals 7. Oh, look how nice that one is. Because that's just another system, right? Then I go ahead and do another system, and then what eliminates here very nicely? The C, so I have 6B equals 12, so who's B? 2. Then I can come plug it back in. I could plug it right there, couldn't I? So therefore I know C is negative 1. And then I go back up into the top. A plus 2 minus 1 should equal 0. So A plus 1 equals 0. So therefore A is also negative 1. With me? Clements? You with me? Where you been? You okay? All right. Just want to make sure. Got me a little nervous. So, is this my answer, just knowing A, B, and C? No. So I want to come back. Can somebody tell me the original equation again? 5x minus 7, is that what it is? 5x plus 7? And it was over x cubed plus 2x squared minus x minus 2. And then notice, who did I have as my A value? So it was negative 1, and it was over x plus 2. Is that what you said? My B value was over who? 2 over x minus 1 plus D, which I could just have, I could either go plus a negative 1 over x plus 1, or I could just go subtract 1 over that. Does that make sense? But it's the goal to get those three fractions that would equal the left side. So we are just going in reverse. That would be the answer. Nope, I want you to write it out. Yes, ma'am. Because we're trying to say, what does this equal in terms of different smaller fractions? If you check it, go have fun. I mean, you can. Hopefully you did your work right. Because if not, that would suck. Yeah. Once again, I want you guys to be prepared. It's most likely a single-hour test again. Just so you're there mentally that it's 1 hour. Last time he was nice and he gave us like an hour, 6 minutes. I don't know if you guys noticed that, but so we'll see. But he did let us review for a lot beforehand, huh? So that was good. All right. Next example. All right, this is a good problem. This is where we get into a little bit different here. That is a plus 1. Is that better? Benji, huh? Benji. Huh? You pull up his picture. I'm teaching a damn lesson. Jeez. Anybody want to help me on how I would do this guy? I would have who? A over X plus B over X plus 1 plus C over X plus 1 squared. This is the part that I'm going to have to explain to you guys. Ladies and gentlemen, what if I didn't have the B section? What if I didn't have this? Would I still be able to maybe get to the common denominator of X times X plus 1 squared? I could, huh? So I have to do it every time. I have to have, if it has a power above it, I got to do its basic power and then the next power. What if I had X cubed on the bottom? What would I have to have? A over X plus B over who? X squared plus C over, because I could have all or any of those three to be able to get to that common denominator. Because what if I only had the first two? Could I get there? Maybe, right? So therefore, anytime it has a power, you got to keep telescoping him up to the highest power. Does that make sense what I'm going for there? Okay, so I'm going to Control Z and undo all this stuff. Okay. Who am I going to times by? Common denominator, which is X times X plus 1 squared. So when I go ahead and multiply that, notice I just get the X squared plus 1. Should I get anything different than X squared plus 1 when I go ahead and times it to my original fraction? I mean, should I get anything but just the top? No, I shouldn't. I should just use that. Okay. The next one, notice the X's would cancel, wouldn't they? So I'd have A times X plus 1 squared plus B, one of the X plus 1's can't get rid of each other, right? So I have B times X plus 1. Yes, ma'am. Because notice X plus 1, okay, so on the A value, who's the only thing that gets rid of each other? I'll answer, okay, let me answer this question. I had to answer it this way. Can I show you this? Let's say I had 2/3 minus a half plus 3/4. Where would be its common denominator at? It'd be at 12, right? Because that's really where 4 and 3 meet. Why did I not care about where 2, 4, and 3 meet? Because 4 is already within, 2 is already within 4. It's the same idea. Does that answer your question? Isn't X minus 1, or X plus 1 part of X plus 1 squared? Does that make sense? Watch what happens when I go ahead through. Go ahead. So what happens here is when I distribute this through, so the X is there, hence him, right? I have X plus 1 squared divided by X plus 1. So I have two X plus 1s, right? And one of them gets rid of each other. So that's why I still have 1. Now on C, X plus 1, I have two X plus 1s, so therefore they get rid of each other. Does that answer your question? Okay. Good questions. You're doing great today, Sid. I appreciate you talking. Everybody else, you're dead to me. Okay? Have you asked me a question yet? Okay, thank you then. You're only somewhat 1 foot in the grave. Everybody else? Dead. Are you trying to get out? The grave? Because it looks like you're going to ask me a question. Okay, then maybe you're getting out. Anyway, go ahead. The what? I don't need more. Uh-huh. No. I don't think so. I don't think so. From what you asked, I don't think it's so. So this just takes some time that you got to go ahead and write this out. That's just part of the goal. Okay, then I'm going to get myself some space, get myself. I know I've been watching me some English goes when I say, I tell you, I don't know, they use me a lot. She got me. No, what the hell is it? I don't know. Anyway, what's number in front of the x squared? 1. So therefore, I'm looking for all the coefficients in front of x squared, correct? So I have A. I have B. Do I have any C's? Nope. And once again, I'm going to cancel them out just to make sure I'm using every term. Does that make sense why I'm putting that? Because obviously if I miss a term, then that's going to hurt my system, isn't it? Okay. Do I have any just pure old x's over here on the left-hand side? So therefore, what's the number should it equal to? 0. Yes, sir. No, sir. Would you like me to screw back up and show you why? Because notice when I multiplied this x plus 1 into this x plus 1 squared times x plus 1 squared, they get rid of each other all the way. Does that make sense to you? Okay. You with me? Okay. So notice I have 2a in front of the x. I also have a b in front of the x. And I also have a c in front of the x. So therefore, 2a plus b plus c should equal 0, shouldn't it? Okay. Do I have anything else left? 1 should equal who? Just a, because he's the only guy that's a regular coefficient, isn't he? Well, hot dog, that just saved some time, didn't it? Because what's a? A is 1. Which that means b is 0. And therefore, c is c plus b, who is 0. 2 times 1 is 2 equals 0. So c is -2. And like I said, I had to have both options. But in my work, with b being 0, do I even write this option anymore? Do I need to? Because what's 0 divided by anything? So he's not even there, and that's why I had to do it just in case it was. You are so kind. Are you really grateful? Uh-huh. Where's Benji taking you on a day date? You don't know your plans yet? Al, are you going to prom? Who are you going with? Johnny, is Johnny gave you your day date plans? What the hell kind of people are these people? That's what happened my senior year. I struggled. I asked a girl that I really had a crush on. And she's like, you know what? I really just don't want to go to prom. And I was like, ouch. She didn't go to prom, though. At least that's good that she didn't go with somebody else. But I was just like, it's the fat guy syndrome, whatever. Anyway, so I was kind of down on myself because this girl that I had a little crush on told me no. But then my buddy, his sister, got asked by a guy, and then the guy's parents scheduled a cruise over prom, and so he had to back out. And so luckily I was the knight in shining armor and just swooped in and took her to be the good guy. Anyway, it was a fun dance. Yes, sir. X plus 1 squared, because you have to understand I could have both situations. I could have an x plus 1 and an x plus 1 squared. For the fact of the matter, don't they still get me to that same common denominator of over here? Because if I put this x plus 1 here, would that change my common denominator over here? No, it wouldn't, does it? But I have to put it here, because do I have to have this term always? As we just saw, it doesn't need to be there in this case, does it? Would these two right here, Adam, get me to my common denominator? Just those two in themselves? Yeah. So I have to have the case where it could be all three. And like I said, if it isn't all three, it's just the two, A and C, like we have, the math will make sure that that happens. I'll just go ahead. So like here, like once again, if I had x plus 1, let's say to the 4th power, I'd have A over x plus 1 plus B over who, do you think? X plus 1 squared. I got to keep going all the way up because I could have that, couldn't I? Because does that change my common denominator? Nope. How about C? X plus 1 cubed. And then plus D, x plus 1 to the 4th. Because what happens there, Adam, is could I have just this guy and this guy? Yeah, that'd still give me the common denominator of x plus 1 to the 4th, right? Could I have just him and him? No. Can anybody tell me why? Because what's the highest common denominator that would be? X plus 1 to the 3rd, right? All I would have to do is times this guy by x plus 1 more time. So the thing I could have by myself is him, but that would mean all these other guys would be 0. But could I not have all those cases and still have the same common denominator? I could, huh? That's why I have to do all those options. Does that make sense to you? Okay. Hopefully that answered your question. So therefore, I'm not done. Remember, this comes out to then we're right the partial fraction. Was it x squared plus 1 or minus 1? Plus 1 over who again? X times x plus 1 squared. And then my a value is 1, so that's 1 over x. My b value is 0. Do I even need to write him then? Nope. Plus my c value was negative 2 over x plus 1 squared. So if you'll notice here, Adam, that I still am able to get to my common denominator by just having these two. Does that answer your question? Okay. Ooh, what's all this? Oh, man. Where did mine go? Did I just close it off? Did I just close it? Hello? Not you guys, but what? No! No! Yes! Oh, thank the Lord! No! We will take a temporary pause. That one of them is just a constant. That means that you would not have anything there, though, because you could, even if it was a constant, you could then adjust that to make it equal into a fraction. All right. Somewhat. I want to try a harder one. These are so far been pretty easy. Usually, these are easy. They're not really hard, they're just tedious. Would you not agree? They just take a little bit of time and paper. Am I exactly right? Yes, Mr. Roberts, you are. I feel like I'm like Sven and Olaf. Not Sven, but who's the dude, the ice guy? Kristoff and Sven. Because you know how Kristoff speaks for Sven sometimes? That's what I feel like when I'm like, a pet reindeer. My friend has pet reindeer. Would you like to see him? He was actually the first veterinarian to artificially inseminate reindeer to actually make them live. Here, I'll show you. He's a vet. He's actually pretty cool. No, you may not. Yes, you can. Okay. I understand what you're going to ask me. And his sister is going to be our track coach, cross-country coach, out in, see, reindeer. He does, those aren't all his reindeer, but he goes around the whole world and he'll help reproduce reindeer. Because he invented a technology that they didn't have prior. He goes on a whole lot of trips. He was one of my college friends, which I really enjoy and appreciate him. He's a great guy. But I don't, ooh, Botlane. There's his reindeer. That's Maximus. That's an alpaca. He does alpacas too. Oh, that's all the, what the hell, Isaac? He like posts. He's out of Springville. See, there's some more. He goes around and speaks a lot. That's his brother. That's his family. This girl right here is going to be the. It's okay. This is Isaac, and if they didn't want to be on vision, they should.
Tigers and bears.
Oh my! That's right. That's Isaac. Just want to see him. See, there it is again. I was actually up there. He actually had a TV show for a little bit, but it didn't go very well because it was only on like Park City TV or something. There's the family again. That's the sister. That's the family. They're all in reindeer. That's actually pretty damn cute. All right, Isaac, I'm back at you, brother. Okay. Anyway, this one's slightly different. But do you guys see how this guy is a sum of squares, so therefore I can't factor him. He's unfactorable, correct? I don't want you guys to have to go solve to see what those are because those would actually be imaginary binomials. And we don't have imaginary binomials, okay? So what we're going to do here is still the same thing. I have a over x, but what in this case that I'm going to do is this is the only other thing I have. But we have seen, especially when we had rational functions, things that were 1 degree less than whatever we had, right? Did we not see something like 3x plus 4 over x squared plus 6x plus 7 before? How's it going? How's your bracket happening? Because I see you keep watching. How's it going? Are you doing the summer tryouts? Did you get that thing? They're going to have team, like not tryouts, but workouts. Did you see that? Yeah. I just want to make sure that you knew because you said that, you know, you got screwed over here. You just might not have as much talent, but whatever. I love you, but we all have, you know, we got to just, I'll shut up. I love you too. I'm sorry that you got screwed over. Now that's why you're going to my school. Okay. Huh? It is my school. It's just like if anybody watched, I get off topic fourth period a lot more. No, fourth period is like if you really want to learn, sorry to you guys, I try my best, but I'm a better B1 teacher than I am a B4 teacher. Anyway, what's that show? And then he talks about how he kills all the English people because he's Irish, Scottish. He wears a kilt, Mel Gibson. I can't think of it. Braveheart. And then he's got a buddy from Ireland. He's like, no, you don't understand. It's my island. My school people. I don't care. But if it's my school, then I treat it up with the utmost respect. Hopefully you treat your items. Yes. But anyway, you should always be 1 degree. What if this was an x cubed and it couldn't factor? What would I have up here? I'd have like ax squared plus bx plus c. I'd have 1 degree less if I can't factor it. Does that make sense to everybody? Yes, ma'am. Yep. Or factoring in general. Yes, ma'am. Yes, ma'am. Okay. So once again, I can go ahead and just times, that yellow is kind of nice. Maybe I should, hold on. You guys want to see something cool? We're going to go like this. What does that look like? You guys like that? Huh? Yeah. So x times x squared plus 4. Isn't that not my common denominator? So I'm left over here. Now I can use this cool yellow and feel good about it. Look at that. You guys are wanting this all day, aren't you? Really? You can't see the blue very well? Sorry. I'm making it pretty for you now. Ain't I so nice? Now when I times that through, notice the x's will cancel out. So I have a times x squared plus 4. This is like the only time I can use yellow. Plus, now I had a good question earlier today. I'm going to put the parenthesis around these guys. Okay, and I'll show you why. Because notice the x squared plus 4s are going to cancel out and I'm left with x. Somebody asked me, Mr. Roberts, couldn't I do it this way though? And you can, but you have to be very clear in what you're doing. What does that look like I would have to do? Wouldn't that look like I do bx plus c times x? You see how that's not the greatest notation? So therefore, that's why I put everything up in the top in parentheses. So I have ax squared plus 4a plus bx squared plus cx. Is everybody okay with what I have there and how I got there? You with me over there? Okay. So notice I'm looking for the things with x squared. So he's a 2. Who over on the right-hand side has an x squared? A and b, correct? Therefore, I know a plus b has to equal 2. Yes. Say again, I'm sorry. The x or the a? Uh-huh. Okay. Yeah, then it would be there, yep. Okay. All right, notice who is negative 1 equal to? Who has just an x with them? Notice he's gone and he's gone, but C himself is the only guy that just has it. So that's nice. I already know what C is, don't I? And then last but not least, B. Who does B equal? Or excuse me, not B. Sorry about that. I didn't mean that. I know that 4 equals who? 4A. Now, like you said, A does equal 1, right? So if A equals 1, what does B equal as well? 1 plus what gives me 2? B is also equal to 1. So that's a pretty easy one, huh? Yeah, it's the bx plus c. Now on the next one, we're going to go ahead and just situate. So let's hurry and write it again. What was the top again? It was 2x squared. I'm guessing that thing right above my face. And our denominator was x cubed plus 4x. That's what we started out at. Would equal 1 over x, correct? Plus my b is 1, so that's x. My c is negative 1, so I'm going to erase that and make it a negative 1. All over x squared plus 4. That would be my answer. Yeah, that's fine. But you would, on your test, understand this is what I'm looking for. Is everybody there with me? Is today really a rough day? I mean, is it a hard idea? It's getting rid of denominators and then doing what? A very basic system of equations. On this question right here, all I want you guys to do is to set it up. All I want you to do is set it up. We don't have to solve, okay? We're just going to set it up. The A, the B's, the C's, and so forth. Just leave it at that. Okay? Okay, I'm going to push pause. I want you guys, so you guys can get the assignment. Here's what we got, because a lot of you guys, anybody think they have it? Did you get it? Where did you get to? A over X, right? Plus B over who? X squared plus C over X cubed. How many of you guys at least got to there? Hot dog. Plus, now I'm going to go on to this guy. Can he factor? Because he can't factor, I do one less term. So what's one less term of X squared? X, so that's dx plus E over X squared plus X plus 1. Does everybody understand how I have that? And this thing in here, factor. So I have, after E is fx plus h plus h, fg, sorry, over x plus 2, x squared plus 2, plus hx plus I over x squared plus 2 squared plus ijx plus k over x squared plus 2 cubed. Does that make sense to everybody? Yeah, he's a quadratic that cannot be factored anymore. So therefore that's it. So therefore I just go 1 degree below it. I do ax squared plus bx plus c type of an idea. Yes. Then I would factor it, and then I'd have just a term like we did at the very beginning with an a above x minus 1 and a b above x plus 2. Does that make sense? Okay. Anybody else? Do you want me to look up like one kind of like on your homework and try it with you? How about we look at number 36 together? This is number 36 out of your textbook or out of the textbook, which is 3x squared plus 5x minus 13 over x to the 4th minus, oh, I did this one earlier. It was a struggle. It's okay. Why not struggle? You guys are nervous of struggling. So this guy is x squared minus 4 squared, which means I have x minus 2, x plus 2 squared. Okay, so let's set it up. I'd have a over x minus 2 plus b over x minus 2 squared plus c over x plus 2 plus d over x plus 2 squared. Does everybody see that? It's not as pretty. I'm going to hurry and show you guys your guys' homework if that's okay. I don't want you to just write those down really quick, just in case if we go over time. It's Travis's birthday. Because these take a little bit of time. Now, once again, like I always say, what do I always tell you? Homework is a minimum standard. So if you believe you need more, that's on you to do more, right? I just try to make sure, hey, if you are able to do these problems, you should be able to do enough, right? Hopefully you guys like that instead of it like being a chore to you or anything. I gotta find my thing again. There it is. All right. So I'm going to go ahead and times by my denominator of x plus 2 squared and x minus 2 squared. Here's what I would get. I would get 3x squared plus 5x minus 13 equals, notice those x minus 2's one of them would cancel, wouldn't they? It's not a bad time. I just got to finish this lesson. So if you want to stick around for a minute, but I just got to finish this lesson. X minus 2, one of those cancels out. So I have a times one of those x minus 2's. And then I have both of those x plus 2's, don't I? Does everybody see that? And then here, both x minus 2's get rid of each other. So I'm left with the x plus 2 squared. Notice one of those x plus 2's cancels on the c. And I'm left with x minus 2 squared. And then d is left with x minus 2 squared. Do you see how that works? You get the idea though? And then what would we do from there? Say again? Then I would have to distribute through. So I'd get, okay, this is x squared plus 4x plus 4. This is x squared plus 4x plus 4. This guy right here is x squared minus 4x plus 4, and I haven't even distributed the other thing through. Do you get what I'm saying by that? So then you got to just keep going. But I don't know if you want me to keep going? We're okay? I sure the hell hope it's not this difficult. I, once again, don't get to write your test, though. Can I guarantee what's going to probably be on there, though? If I was the teacher, what would you think would be on there? Something telescoping, right? So like something squared, so that you'd have to telescope it up. Does that make sense what I'm going for? And then I guarantee there'll probably be something that has like a lower, like an x squared that doesn't factor, so that you have the bx plus c on top. If I was a teacher, I'd have one of those on there of each. Okay? All right, guys, thank you so much.